in all, so I'm going to run through the October half term mock again just to help with those getting stuck on the revision sheet. So remember, anytime you get an algebraic fraction that you need to put either into a single fraction, you need to simplify it in some way, add or subtract fractions, don't go expanding, okay? What you want to do is factorise as much as possible first. You'll probably find there's something that can cancel out to begin with. So if you factorise this one, we're going to leave the top of the fraction exactly as it is. And if you factorise the bottom, remember that's the difference of two squares. Since 9x squared is obviously a squared term, 4 is a squared term with a minus in between. So you get 3x minus 2 and 3x plus 2. That means that before we start, what I can do is cancel out the 3x plus 2 on the first one. That leaves me with 2 over 3x minus 2 minus 2 over 3x plus 1. So to be able to put them into a single fraction, I need the denominators to be the same. So I'm going to multiply top and bottom of this one by 3x plus 1, and then top and bottom of this one by 3x minus 2. So I get 2 lots of 3x plus 1 over and our 2 brackets, which are 3x minus 2 and 3x plus 1, minus, and then 2 lots of 3x minus 2 over and again both brackets. At this point, once you've got the denominators the same, this is when you can start thinking about expanding brackets. You will never have to expand the bottom, okay? You only need to tidy up the top. So if I expand the top of this one, I get 6x plus 2 minus, and now be careful when you expand this one, treat it as a negative 2 outside. Minus 2 times 3x would give us minus 6x. Minus 2 times minus 2 is going to give us a positive 4 over, and I can now write both of them over one denominator. That means 6x take away 6x is going to cancel itself out, so I just end up with 6 over, and the two fractions, 3x minus 2 and 3x plus 1. Okay, if we look at the second one, now this is one that you've got the formula sheet for, and I did put it up on Show My Homework. It gives you the small angle approximations in the actual exam booklet. Okay, all you need to do is replace everything with what it's got in the question. So what I've got there, sorry, light just sort of went off there. We've got cos theta is roughly the same as 1 minus theta squared over 2. So I can replace that with 1 minus theta squared over 2 minus, and then sine of a half theta. Well, sine of theta is roughly the same as theta, so sine of a half theta would be roughly the same as half theta. So I've got minus a half theta, and then plus, and since tan theta is roughly equal to theta, that's just 2 theta, which is equal to 11 over 10. Now, what I can do is, because I basically want to end up with whole numbers, I want to cancel out any denominators. Since the lowest common multiple of 2 and 10 is obviously 10, I'm going to multiply all the way through by 10. 1 times 10 is 10. If I multiply this fraction by 10, it's going to cancel out with a 2 to leave me with just 5 theta squared. Same on there, 2 is going to cancel, going to give us 5 theta. 2 times 10 is then 20. And obviously, if I do 11 tenths times 10, I get 11. All we're aiming to do is get the theta squared positive. So I'm going to add 5 theta squared to both sides. So I get 10 minus 5, plus 15 theta. That's just minus 5 theta, add 20 theta is going to give us positive 15 equals, and then 5 theta squared add 11. Sorry, pen's playing up there. All we're going to do is, if I then subtract 15 theta, I get 10 is equal to 5 theta squared minus 15 theta, add 11, and if I subtract 10, I get 5 theta squared minus 15 theta plus 1 is equal to 0. Obviously, you could put the equal to 0 at the start if you're keeping it all in order, and that's all they want you to do. Okay, I'm just going to figure out what's going on with the lights, so I'll do a video for the next one.